Have you ever really looked at the salt on your table? Or a diamond ring? Or maybe just a plain old ice cube? Well, it turns out they've all got a secret life, a story to tell about what makes them, well, them. And in this explainer, we're going to lean in and listen.
So meet Arav. He's going to be our guide on this journey. See, he looks at the world and sees so much more than just stuff. He sees these hidden stories, secrets locked away inside the most ordinary things, and he's absolutely determined to figure them out.
One day, he finds this tiny, perfect little crystal. And instead of just admiring it, he gets right up close and whispers a question. Who are you really? And you know what? He actually gets an answer.
The very first voice to speak back comes from a salt crystal, and just like that, it pulls Arav into the amazing world of ionic solids.
What a perfect way to put it. Just imagine a dance floor, right? It's packed with positive and negative partners, and they're all so attracted to each other that they form this rigid, perfectly ordered pattern. They are locked in a super tight embrace, and they are not letting go.
So, here's the science behind that tight embrace. It's all about this incredibly powerful, almost magnetic pull between positive and negative ions. This isn't just a casual friendship, it's a fundamental force called electrostatic attraction, and it defines absolutely everything about these solids. And because of that super intense bond, Arav starts to uncover their secrets. It takes a ton of energy, we're talking a lot of heat, to pull them apart, which is why they have such high melting points. They're incredibly hard, for sure, but if you hit them in just the right spot, that perfect rigid structure just shatters. They're strong, but they have zero flexibility.
Okay, let's keep going. Just when Arav thinks he's getting the hang of it, two completely different characters show up, but they're both made of the exact same stuff. Welcome to the truly fascinating world of covalent solids. Isn't this wild? It's a total contradiction. How on earth can two things, both made of pure carbon, be so incredibly different? I mean, one is literally the hardest substance we know, and the other is so soft we put it in pencils so it will rub off on paper. The secret, it turns out, isn't what they are, but how they're built. So, unlike ionic solids, where it's all about giving and taking electrons, covalent bonds are all about sharing. Atoms share their electrons, and in doing so, they create this unbelievably strong, interconnected web. It's not just two atoms holding hands. It's like an entire city of atoms all linked together in one continuous grid. And this right here just lays it all out perfectly. In a diamond, every single carbon atom is locked into a super rigid 3D cage with 4 of its neighbors. There's absolutely nowhere to go. But in graphite, the carbon atoms form these flat sheets, kind of like chicken wire. The sheets themselves are strong, but the connections between the sheets are super weak, so they just slide past each other. And there it is, the big aha moment for Arav. This is one of the most fundamental rules in all of science. Structure is everything. You can have the exact same ingredients, but if you change the blueprint, you get completely different results. Next up, Arav's eye is caught by this little glint of light from a copper wire. This is his introduction to our third type of solid, a character that's all about freedom and movement. I just love that description. Get this picture in your head. You have this orderly kingdom of positively charged metal atoms, right? But their outermost electrons, they aren't tied down to any single one of them. Instead, they're just free to roam, to wander, throughout the entire kingdom. This idea of a sea of electrons is the whole key to understanding metals. It acts like this flexible, conductive glue. It holds all the positive ions together, but it also lets them shift around without the whole thing breaking apart. That mobility, that's the source of all of metal's superpowers. So what does that mean in the real world? Well, that free-flowing sea of electrons is exactly why metals are malleable. You can hammer them into thin sheets. It's why they're ductile. You can stretch them into wires. Those mobile electrons are the perfect couriers for electricity and heat, and the way they interact with light is what gives metals that classic shine.
For his final lesson, Arav turns his attention to something much softer, something that can literally vanish with just a little bit of warmth. He's about to meet the most delicate members of the entire solid family.
Right. So think about an ice cube. Inside each individual water molecule, the bonds holding the hydrogen and oxygen together are really strong. But the forces holding one water molecule to the next water molecule, those are pretty weak and easy to break. It's less like a super tight grip and more like a group of friends just holding hands loosely.
That is the absolute defining feature right there. We're not talking about the super strong bonds between atoms anymore. We're talking about intermolecular forces, the forces between the molecules. And because those forces are so much weaker, it's way easier to pull the whole structure apart.
This connects directly to all their properties. They tend to be soft. They don't need a lot of heat to melt, because those weak connections just snap apart. And a lot of them can turn straight into a gas, because the molecules are just so eager to break free and fly away.
And there you have it. Arav has met 4 totally distinct personalities from the secret world of solids. So let's put all of their stories together on one page and really see how they stack up.
This chart just nails it. You've got the unbreakable grip of ionic solids, like salt, the vast shared network of covalent solids, like diamond, that flexible conductive sea of electrons in metallic solids, like copper, and finally, you have the gentle, loose connections of molecular solids, like ice. 4 completely different ways of bonding, leading to 4 completely different kinds of materials.
And in the end, Arav gets it. The world isn't just made of stuff. It's made of stories. It's made of relationships between atoms and molecules. The structure, the bond, the way they're all put together, that's what gives every single material its own unique personality.
So Arav's journey has introduced us to the 4 main characters in the story of solids. But, the world of materials is huge, and it's filled with even weirder and more wonderful tales, which really just leaves one question.